Yeah, I threw it away. I don't. Yeah, I didn't get far enough. All right. So day 2 of the sum to product to sum identities. Very exciting. If you don't know your identities, these questions can be very, very difficult. If you know them, very easy. And we talked about yesterday how you can get by if you don't know. There's things you can do to get by. And we talked about how they just save you steps in your thinking. So, it should be a nice one today. I think we might even have a 5 for 10 for a good grade today. Did we do this one?
Yep. Yeah.
And we did this one.
No, we're on the world.
Ah, here we go. I like this one. What's wrong, Kaylee?
Wait, would our 5 for 10 be over?
Oh, good. All right, it'll be our last section.
6-3.
You bet. Yeah, it is. All right, so which side would you like to work on? This is just like the homework questions we talked about before I started recording. All right, so what is cosine U, cosine? This is a difference. So I write this as -2 sine of A plus B divided by 2 and sine of A minus B over 2. See how easy that is? If you got your note card, piece of cake. If you don't, well, then go to the other side. Give it a go. The bottom one's going to be 2 A plus B over 2 and cosine of A minus B over 2. Fantastic. And like I said, these are all multiplied. Multiplied, 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 multiplied. So you can cross these off. See that 2 and that 2? Since all the numbers are multiplied, you can start factoring and start crossing off like terms. Sine over cosine becomes what? Tangent of the same angle. Tangent of 1/2 A plus B.
Still be negative, though, wouldn't it?
Oh yeah, you're right. Negative still comes down right there. And sine over cosine will again be tangent of 1/2 of A minus B. That's done. See how easy it is if you know your identities? I had this talk yesterday. I'll have this talk today. I'm not sure I had this talk in this class. You get closer to the final exam, you're going to be experiencing a little bit different type of grading. On this one, if I was at Parkland, they score by a rubric. If this would be worth 4 points, they give you 2 points for this step, 2 points for that step, 4 points total will be your credit. If you are in high school and you make this mistake, if you forget the negative right there, the teacher usually gives you the good student discount. Oh, they know it's supposed to be there. I'll just take off a 1/2 point. Your final will not be graded like that. Your final will be graded as if you were a college student. So if you make a mistake in your logic and you forget that negative and your grade is, and you miss that first line of logic, how many points do you think you're going to get if that first step is wrong? 0. If you don't have the first step right, there's absolutely no way you can get the second step right. That's why scores of 8 out of 52 are very possible. It's because you're used to the good student discount, which you don't get when you go into college. 1, they don't even know you. And 2, you're expected to remember. You have higher expectations. So your test coming up next week or 2 will have partial credit that's eligible, but it's partial credit that's earned. Okay? For every step you get correct in a logical sequence of thought and reasoning, you're rewarded for every step that's correct. Every step that's incorrect costs you and has consequences for the entire problem. Okay? So you're asked to elevate your game, so to speak. Calculus has been going through it for close to a semester and a half now. You guys are just getting ready to start. Yeah.
So what if we did manage to get the second part right but not the first?
That's logically incorrect. If you have the first wrong step, there's no way you can have a second correct step. 2 negatives don't make it a positive in that case. Okay. All right. So you can, start getting used to being a little bit more accurate on your steps. Oh, verifying the identity. This is a great one. Well, I think it's great. We have 2 choices. It's a classic. Usually seen on quite a few tests. You can use whatever letter you like. They have no misguided agenda for using T. It's fine. Okay. Any ideas how to do this?
No, because they're all plus signs, so you keep like crossing them out.
They are all plus signs, but if you look at it very carefully, and you see there's a 4 right there, you know you're going to add and divide by 2, right? So maybe if you grouped it by using these two, turning it into a product. Yeah. So if you took cosine of t plus cosine 7t, you can't keep looking at something the same way if it's not working. You have to adjust your thoughts. Some people call that thinking outside the box. That means just adjusting your thought, looking at things in a different light. Plus sine of 4t. Some people are very good at it. Some people never experience it. Just on how you look at things. Now I can take these two expressions and write them as a product, not as a sum. So, and also take a look. I preserve the 4 t's that are in my answer. See how the 4 t's are in my answer? Yeah. So cosine plus cosine turns out to be what? Yeah, 2 cosine of a plus b divided by 2, so that'd be, well, I'll just spell it out for you. And then, what's the next one? Yeah, cosine of t minus 7t all over 2. Divided by, anybody thinking this is going to be 2 sine? A plus b over 2. Cosine of a minus b over 2. T minus 7t over 2. Interesting.
Wait, so what'd you do with
I don't.
cosine 4?
Huh?
What'd you do with the cosine of 4?
I just left it right there. It's still here.
Okay.
Cosine of 4t. And also, the sine of 4t is still there. Okay? Nice! All right. I don't know if this is right or not. That's why you do mathematics in pencil. So you have 2 cosine 4t, cosine 3t. Actually, positive or minus doesn't matter to cosine because it's an even function, so it stays even. Plus cosine 4t all over 2 sine of 4t, cosine of Wouldn't what? Wouldn't what? Oh, you can't cross anything out because you have this plus sign. It's not all multiplied. Yes, Marissa?
When you do in the on top.
Yeah? Right, you get cosine of negative 3t. Right, because we have an odd and even function on our identity note card. Cosine of negative 3t is the same as cosine of 3t. Now, if it were sine, it would be out in front of the expression. Okay? So, now we come down to this. Remember, you're still trying to get cotangent of 4t. Any thoughts, ideas? Exactly. Look at that. You can't cross things off, but you can still go back to the old GCF. If you factor out a cosine of 4t, look at what you're left with. 2 cosine 3t plus 1 all over sine 4t times 2 cosine 3t plus 1. Now they're multiplied. Okay? Now they're multiplied. So I can cross off this whole thing. Look at that. That's a thing of beauty. Cotangent of 4t equals cotangent of 4t. Huh? Problem solved. Just like climbing a mountain. What do you see when you climb a mountain? You see another one.
That's right.
And you got to climb it.
A lot about the climbing.
It is.
Hope you have good shoes.
Great shoes. All right, ready to move on? There used to be a mountain climbing problem in Trigg. This one looks easy.
You just have to do one of those, so.
Yeah, let's not do that.
Yeah.
That looks easy. I'll just let AU equal V, and I'll let BU equal, or B and A. Yeah, it's that cosine, cosine. Yeah, it is. All you do is express it as a sum. Yeah, easy stuff. There we go.
There we go.
That's what I want to do. I want to solve some things. Okay? I want to solve some things. Use it to find the solutions of the equation. What?
So we solving for T then?
We are solving for T. It doesn't give you a domain, so you can assume that you're finding all solutions, which makes you very proud and happy because you put a plus 2 pi in.
Still.
Nice. Any thoughts or ideas?
Don't you have to subtract the sine from the-
I could. Does anybody want to address this?
Yeah, do the sine plus sine first, the 2 sine of.
Yeah, if I do that, I can do 2. Is it 2 cosine or sine? 2 sine.
And I don't know how I'm supposed to do that.
Practice.
Over Q.
Cosine of 2
All right. All right. So t plus 3t is 4t divided by 2. 2 sine of 2t. And this becomes negative 2 cosine of negative t equals sine of 2t. Now what happens to the negative? Yeah, it turns into a positive. And how do you think you're going to solve this now? Now it looks kind of easy. Yeah, subtract it over. So I have 2 sine of 2t. Cosine t, remember that's from the odd and the even property.
And then
Yeah, subtract the sine of 2t.
you can factor out
Exactly. Just like on the quotient problems, once you get to the factoring, you can do a lot of things. Yes?
I thought on some you put the negative in there.
Because on some it said sine of negative theta equaled negative sine of theta, and on some it said cosine of negative theta equals cosine of theta. It's on your note card in the even and odd identities. Okay?
But that comes down to 50.
Well, I just did it to show the first step. I actually should have went straight to the positive, but I just wanted to show the intermediate step. Okay? So,
when you get full credit.
well, not full credit, but some people, I want them to actually see it turns into a positive. Especially for like people like Megan who are watching this at home later this afternoon. All right, factor it out.
So wouldn't it be sine 2 negative sine of
Right, 2 cosine t minus 1. And now you have the pigeonhole principle.
Set each of those equals 0.
Yeah,
When you substitute theta in for 2t or t.
you could. I think we've all done that enough that we know how that works. Maybe we can still write it in, I don't know. But I do know that I can set them both equal to 0. And what angle makes sine equal to 0? Yeah, 0. Do you want me to use a let statement or just everybody knows it, how it works now? Okay, so I can have 2t equals 0 plus 2 pi n, or 2t can equal pi plus 2 pi n. And what about when cosine of t, when cosine of t equals 1/2? Which ones are those going to be? What angle makes the ratio equal to 1/2 for cosine?
Pi over 3
Pi over 3?
and pi over 3.
Pi over 3, very good, plus 2 pi n. And 5 pi over 3 plus 2 pi n. That comes from those two. I know, some of you are like getting older. You can think for longer than like a minute and a half. It's great.
You wouldn't have to check any of your ends, though. We could have to say between 0
Right, you wouldn't have to check in your ends. The only thing you have to do is simplify that one down. And you have all 4 solutions. T equals 0 plus pi n. And t equals pi over 2 plus pi n.
That's a nice looking egg.
Yeah, or t. Nice. So, look at that. A little walk through the park, generate all the solutions. You can find any one you want. And that only took, a few steps. The one on the right came from the cosine being a half.
Huh. That was 28.
That was 28. Nice. I like that. Questions? Or are you just in shock of like the great power of mathematics?
Yeah, it's like,
Yeah, that's part of it.
Nice. Yeah, we can do this one. Use the standard product to find the solutions. Would you like to start on your own, or would you like to work it together? How about this? I'll let you write it down. I'll let you get started, and then I'll just ask you questions as you're solving this where you're at.
Give this all.
Okay? I know, the first thing to do is so hard. You have to, write it down. Well, usually you set equals 0. That's a start. Sure. If you want, yeah. And everybody, like Devin, what did you do for the cosine identity? Nice. You bet. It would be. She does. Let her in. Lacey, you can let her in now. And that equals 0. So I can set all the factors equal to 0, can't I? Fantastic. So,
two go with the cosine.
well, the 2 can go with the cosine, or the 2 can go away. It doesn't matter. Because you're going to divide by 2, aren't you? 0 divided by 2 is, all right. Yeah. Run it right through there, boom. So the cosine of 9x over 2 equals 0, or the cosine of 3x over 2 equals 0. What happened to the 2? Well, you divide both sides by 2. How's that? 0 divided by 2 is still going to be 0. All right. Yeah, where does cosine equal 0 at? Okay, so I got pi over 2 plus... All right, if it's pi over 2 and 3 pi over 2, how far are they apart in radians? Yeah, can I just do one equation instead of 2 of them? Because it's asking what angle for theta does the cosine of theta equal 0 at?
So we get pi over 2 plus pi n.
Yeah, maybe we could do one equation, pi over 2 plus pi n, since they're only, 180 apart. We do for trig functions that have tangent or cotangent, because their period's pi. Cosine is 0 at pi over 2. Okay. Now, we were just talking about the fact that if we used pi over 2 and 3 pi over 2, maybe we could just add pi to it, because they're half a circle apart. If you don't want to do that, you can do this. 3 pi over 2 plus 2 pi n makes no difference to me. 9x over 2. 9x over 2. All right? And then where does, hey, wait a minute, cosine equals 0. Same thing. I like this. And 3x over 2 equals 3 pi over 2 plus 2 pi n.
You used to do the same pi over 2 with pi.
Right. You could do just one equation also. Now,
blue without the 2.
who?
One equation.
Yeah.
Blue without the 2.
Yeah, you could do that. You could either do the blue equation or the pink equations. Yeah.
Why did you do the blue equation?
Well, some people didn't see why I could just write it as plus pi n. So I said, that's fine. You can write 2 equations with the 2 pi n. You know, some people like one equation to work with, some like two. Now, on the last one we did, it needs to be pointed out that we didn't have that possibility because pi over 3 and 5 pi over 3 aren't pi apart. They're more than pi apart. So you can't, sometimes you can, sometimes you can't.
So depends.
It all depends. That's why you have the power of analytical thought for axiomatic principles based on fundamental trigonometric identities. That sounds cool. All right.
Words now.
So what does x equal if I multiply by 2 and divide by 9?
Do not understand.
What, multiply by 2?
Yeah, multiply by 2 gets rid of all that.
Divide by 2 is,
Wait a minute. Let's slow down then, okay? 2 and 2, 2 and 2, okay? So
So 9x.
I'll do this in steps. So 9x is equal to pi plus, this is supposed to be a 2 pi right there. If I'm going,
You
Two.
said that was only pi because you did,
I said I could do 2 equations or 1. So right now people are going different routes. 4 pi in, and I could have 9x equals 3 pi plus 4 pi in. Now I'm going to divide by 9, right? Very good. So I end up with, right, x equals pi over 9 plus 4 pi over 9 in. And the next one would be x equals pi over 3 plus 4 pi over 9 in. I know, isn't that great? On the right, left, I'm going to do one equation. There, I'm just going to do one equation over here. 3x over 2. So I'm going to have 3x over 2 equals pi over 2 plus pi in. Multiply everything by 2, you get 3x equals pi plus 2 pi in. Then divide by 3, pi over 3 plus 2 pi over 3 in. Right? So you could go with the 4 equation route or the 2 equation route, and I went in between. I went with 3. Right. That was fun. I rather enjoyed that. Did you enjoy it, William? It's nothing more relaxing. Do a little mathematics in the morning, afternoon, just to stimulate the logical thought process. No. Tomorrow's Friday. Sure we do.
no, we can finish, like, we have like 10 more problems, and then
10?
it goes to 43.
Yeah, it's real short.
That's short.
So we can just finish.
Piece of cake.
scroll down.
Scroll down.
And tomorrow.
I got like 5 people talking to me at once. And I'm doing a great job of listening to all 5.
What I say.
I said, listen.
Didn't say you understood.
All right. So, what's next, William?
Somewhere in the 35 area.
Oh, we talked about this last time. What do you do on these problems? Let's see if you remember anything.
Put it in the white one.
Yeah, you can do y1 and do graph, intersect, and 0, right?
Let's see if I can grab it.
Correctly.
All right, so that takes care of that one. Oh, well, look, that's the last one. I don't know what just happened.
Stop and fix it.
What word problems?
There's like,
What do those say?
no, there's,
How you put in your calculator?
I don't know. Shut up.
Sine of 4x minus sine of x. There you go. So, with that said, on page 508, hold on.
what, I wanted to finish this.
Well, you're not going to
Well,
finish
few
it.
words.
Yeah, we'll just go through 35.
Mine didn't.
Wait, hold on a second.
So I'll go through 35 odd.
No.
I believe we left off with around what, 15, 17?
Yesterday, 23.
Okay. So we'll do 25 through 35 odd. Fantastic. And now the
Moment of truth.
the 5 for
Are
10.
we supposed to be in a specific mode?
Radians, of course.
Radiant?
All right, I'll shut this off,
Yeah.
and I'll give you your problems. What page you on for the 5 for 10?
6-3.
Page what?
Uh,
Page 490. Very good.